Hey friends! Welcome to the next section, Database Progression to Database Regression. In this section, we will define statistical regression concepts and outline how a developer might use regression for simple forecasting and prediction. Now we move to the first video, Introduction to Statistical Regression. This will provide us with clear explanations of what statistical regression is. For starters, statistical regression is also routinely referred to as regression analysis, and is a process for estimating the relationships among variables. This process encompasses numerous techniques for modeling and analyzing variables, focusing on the relationship between a dependent variable and independent variables. An alternate objective of the process of regression analysis is the establishment of location parameters, or the quantile of a distribution. We'll explore some real-world examples later, but for now, let us look at some techniques for the process. You'll find that various techniques for carrying out regression analysis have been developed and accepted. Some of the top techniques are linear, logistic, polynomial, stepwise, ridge, lasso. Linear regression. Linear regression is the most basic type of regression and is commonly used for predictive analysis projects. In fact, when you are working with a single predictor or variable, we call it simple linear regression, and if there are multiple predictor variables, we call it multiple linear regression. Logistic regression. Logistic regression is a regression model where the dependent variable is a categorical variable. This means that the variable only has two possible values. If the dependent variable has more than two possible values, one can use various modified logistic regression techniques, such as multinomial logistic regression, ordinal logistic regression, and so on. Polynomial regression. When we speak of polynomial regression, the focus of this technique is on modeling the relationship between the independent variable and the dependent variable as an nth degree polynomial. Polynomial regression is considered to be a special case of multiple linear regressions. The predictors resulting from the polynomial expansion of the baseline predictors are known as interactive features. Stepwise regression. Stepwise regression is a technique that uses some kind of automated procedure to continually execute a step of logic. That is, during each step, a variable is considered for addition to or subtraction from the set of independent variables based on some pre-specified criterion. Ridge regression. Often, predictor variables are identified as being interrelated. When this occurs, the regression coefficient of any one variable depends on which other predictor variables are included in the model and which ones are left out. Ridge regression is a technique where a small bias factor is added to the selected variables in order to improve this situation. Therefore, ridge regression is actually considered a remedial measure to alleviate multicollinearity amongst predictor variables. Lasso regression. Lasso, least absolute shrinking selector operator regression, is a technique where both predictor variable selection and regularization are performed in order to improve the prediction accuracy and interpretability of the result it produces. In addition to the aforementioned regression techniques, there are numerous others to consider, with, most likely, more to come. With so many options, it's important to choose the technique that is right for your data and your project. Popular data science opinion declares determining an objective as establishing the purpose of a statistical analysis effort, then splits the purpose into three areas. 1. Summarizing data. 2. Exposing and exploring relationships between variables in the data. 3. Testing the significance of differences between variables or groups within the data. Summarizing data. If your statistical objective is to summarize data, you generate descriptive statistics such as mean, standard deviation, variances, and so on. Exploring relationships. If your statistical objective is to look for and learn about relationships in your data, you first examine your data for a form or, in other words, ask the question, does your data revolve around frequencies or measurements? From there, the number of predictor variables will dictate to you what regression or other approach you should use in your project. testing significance of differences. If your statistical objective involves testing the differences between groups found in the data, then you start out by identifying both the groups as well as the number of those groups. Data analysis involves data with a single group of interest, leverages, compares values to, a mean, while data with more than one group can use the number of groups to determine which predictive approach one should consider.